My name is Gamanji, and currently I am a senior field engineer at Apple. I have joined Apple 3 years ago, and as part of this role, I am bringing Kubernetes and cloud-native expertise to different teams and products within Apple. As well, in addition to that, I am one of the TOC, or Technical Oversight Committee member for CNCF, or Cloud Native Computing Foundation. In this role, I am joining 10 other champions within the industry, and we aim to bring and provide a technical vision for the wider CNCF landscape. I have many other roles in the community, one of them being the creator of the Cloud Native Fundamentals course, which you'll be able to find on Udacity. In addition to that, I am one of the co-lead creator of the KCNA, or Kubernetes and Cloud Native Associate Certification. And finally, I am an industry-awarded professional. I have won the Next Generation Leader for the Women in IT Awards and Tech Women 100 within the UK. Today, however, I would like to talk about sustainability chronicles, and more specifically how we can innovate for green technology by using tooling such as Kepler and KEDA. And to begin with, I would like to introduce the notion of cloud sustainability. Here I would like to emphasize why it is important for the tech sector to take action when it comes to their emissions. It is very important for us to observe, assess, and address our emissions. Next, I would like to apply sustainability to a cloud-native context. Pretty much, how can we measure our emissions within a Kubernetes cluster? For that, I'm going to introduce tooling such as Kepler for creating this inventory of our emissions, and the KEDA Carbon Aware Operator, which will allow us to scale our applications based on carbon intensity. And finally, I would like to talk about community sustainability. Now, while the technology is the gravitational point of our ecosystem, none of it would be possible without people around it. As such, I would like to emphasize why it is important for us to lead for a culture of innovation and create the next generation, actually create a space for the next generation of cloud-native practitioners to operate in. Now, of course, before I move forward, I would like to congratulate our community for a wonderful milestone. Kubernetes has turned 10 years old. We had wonderful celebrations all around the world last year, and I'm pretty sure you've seen all of the cupcakes with the Kubernetes logos on top of it. Now, this is a wonderful milestone for our community because as a community, we're working on software that really changes entire industries and sectors and how they approach platform build-out and infrastructure maintenance. And this has been extremely beneficial for Kubernetes because over time, multiple tools were created around it to extend its functionalities, such as support for different networking, storage, service mesh systems, and so on. And this created what today we know as the cloud-native landscape, which resides under the CNCF umbrella. This is also the landscape that we, the TOC, are constantly working with. We are liaising with projects individually and ensure they reach the maximum maturity level. Now, currently within the CNCF, we have more than 180 projects which are dispersed across 3 different levels of maturity. We have sandbox, incubated, and graduated projects. Now, sandbox projects represent these greenfield ideas. They provide a solution for a niche problem space. Next, we move to incubated projects, and here we already see usages in production, but more importantly, we see contributions from different organizations. And finally, we have the graduated projects, and these are the projects that usually provide the industry standard for the area they operate in. We also refer to these projects as the ones who cross the chasm, so pretty much moved from early majority to early adopters. Currently within CNCF, we have 113 projects which are in sandbox, 37 are incubated, and 26 are graduated. I would also like to draw your attention towards the faint green line at the top of the graph. This represents our archive projects, and I don't think we talk sufficiently about archival. Sometimes it is natural for some of the projects not to reach that momentum in contributorship or adoptership. I think it's very important for the maintainers to take the lessons learned and redirect their energy either to existing projects within the ecosystem or creating a new project and open sourcing that. And currently we have 7 projects with archival status within CNCF. Now, considering the ongoing success for Kubernetes and the growing cloud-native landscape, you can ask yourself why sustainability matters, but more importantly, why does it matter now? The short answer to this question is that currently we have multiple incentives to intertwine the economic growth with climate responsibility. And this happened because of 2 main factors. The first one is COP21, which took place in Paris in 2015. This led to an international agreement to keep the global warming between 1.5 and 2 degrees Celsius. The second factor is the United Nations SDGs, or Sustainable Development Goals. SDG 13 focuses on climate action, and it emphasizes that as a population of this globe, we need to be more responsible and proactive in how we address climate responsibility. Now, both of these factors resulted with regulations at the international level, which in turn resulted with different organizations reporting their greenhouse gas emissions. And we can see the numbers as well. Currently, the tech sector is responsible for 1.4% of global GHGs, or greenhouse gas emissions. Now, if we move towards using renewable energy for powering our data centers and infrastructure, our emissions would drop by 80%. However, if we don't do anything, we'd go from 1.4 to 10% within the next year. As you can see, we are at a crucial point, and we really need to think about sustainability as part of our production checklist. We need to drive these remediation strategies, build expertise in-house, and ensure sustainability is thought about at every single decision-making process. Now, as part of this mission, we already have the big cloud providers setting very ambitious goals for net zero targets. And these are going to be categorized in two main domains. The first one is using renewable energy, and the second one is offsetting their carbon footprint. Now, for renewable energy, we already have Google running on renewable energy since 2022. We have AWS and Azure aiming to do so by the end of next year. When you look into offsetting the carbon footprint, AWS aims to do so by 2040. GCP and Azure aims to do so within the next 6 years. In addition to that, we have Microsoft setting further ambitious goals for themselves, aiming to reduce deforestation, be water positive, and achieve zero waste certification. However, even if you use a cloud provider to fully provision your infrastructure, you should not delegate sustainability to the cloud providers. You need to integrate this thought within your organization as well. And this led to the creation of a new school of thought, which is known as GreenOps, which derived from the FinOps Foundation. Now, GreenOps encapsulates all of the tooling, processes, cultural, and behavioral changes related to digital and climate sustainability. Now, why derived from the FinOps Foundation? This is because we can see a direct correlation between an efficient management of your infrastructure and having a positive sustainability impact. So, for example, if you're new to FinOps, these are all of the practices to observe and measure the cost for your infrastructure, but at the same time to reduce the cost for your infrastructure. So, for example, if you're using FinOps practices, you might use pod instances, or perhaps you moved from using a SaaS solution to serverless. Perhaps you are using a different programming language to optimize your application for the environment it is running, be it a container or a VM. Now, all of these practices will result in using less compute for your infrastructure, which means less cost, but less compute means also less emissions, and by default, we have this indirect sustainability impact, positive impact as well. In addition to that, we already have this correlation between the FinOps team and the sustainability teams that are coming from the latest FinOps report as well. Now, in addition to that, we have the Environmental Sustainability Working Group from the FinOps Foundation coming up with a strategy on how to integrate sustainability as part of the organization. And this strategy is going to be composed of 4 main phases. The first one is going to be awareness. Here's where I'd like to introduce sustainability to the internal stakeholders. You want to talk about terminology such as carbon footprint, net zero targets, GHGs, greenhouse gas emissions, and so forth. You want to gauge the interest, but at the same time, build that momentum. Next, we have the value discovery stage, and here's all of the POCs are happening. The main important goal here is for you to create the baseline. We are not looking if your emissions are good or bad. We are looking to create this baseline. Now, if you're using a cloud provider, you'll be able to use one of their sustainability calculators or carbon footprint calculators, or tooling such as Kepler are going to be quite useful at this stage as well. Next, we're going to have the roadmap, and here is where we introduce the automation. You want to introduce these processes as part of your day-to-day operations. Another thing you want to do here is address and identify all of the anomalies, because we're looking for qualitative assessment of our emissions. And finally, we have execution and repetition. The main goal here is for you to set very ambitious goals for your sustainability. Perhaps you want to achieve net zero targets. And very importantly, in an iterative manner and ambitiously, aiming to achieve those goals as well. Now, at this stage, we can see that the tech sector plays a crucial role in observing and addressing their emissions. We need to build this muscle of carbon accounting and build an inventory of emissions for our product team and the wider organization. So the next question is, how can we do so within a cloud-native context? How can we do so within a Kubernetes cluster? And for that, I'm going to introduce 2 tooling, Kepler and KEDA Carbon Aware Operator. And before I talk about any of this tooling, can I have a very quick show of hands? How many of you have heard about Kepler before? Cool, I have some hands. How many of you have heard about KEDA and the Carbon Aware Operator? Not so many, actually. Cool. Okay, since some of you are new to this tooling, I will ensure to be as declarative as possible to ensure that everyone is going to be following on the journey as well. Now, let's start with Kepler. Kepler is a Kubernetes-based efficient power level exporter that uses eBPF to probe energy-related stats for your system and export this to Prometheus as metrics. Now, Kepler was created by Red Hat and IBM in 2022, and it was donated to CNCF as a sandbox project last year. And I'm going to put my TOC hat on here. As you can see, Kepler is a sandbox project. It provides a greenfield idea or a solution for a niche problem space. When we're talking about sustainability, it's still an emerging space within our ecosystem. As such, if you're thinking about sustainability within your organization, or if you're already on the journey, I definitely encourage you to check out Kepler, but more importantly, reach out to the community. If you have any feedback in regards to using the tool or any functionalities you'd require, do reach out to the maintainers and interact with them through the GitHub repository. Now, let's look into the Kepler deployment. Kepler is going to be deployed as a daemon set, which means we're going to have a replica of the Kepler exporter on every single node. And this will allow us to collect two levels of metrics, node level metrics and container level metrics. We're going to use eBPF to trace CPU performance counters and Linux kernel trace points and export all of these metrics to Prometheus for data aggregation and visualize it with a tool such as Grafana. Now let's look into how Kepler calculates our emissions. The first thing we're going to need is going to be the input value. This is going to be the amount of energy consumed by our application. Kepler is going to calculate that in joules, and it's going to convert that in kilowatt hour consumed. Now we're going to multiply this input value by an emission factor. And the emission factor is the pounds of CO2 or carbon dioxide emitted per kilowatt hour consumed. Now, currently, Kepler is going to calculate the emissions for three main gases. It's going to be coal, petroleum, and natural gas. And as you can see, these are hard-coded coefficients, and they are depending based on the provider, the energy provider that you're using, the country and region that you're running as well. In this particular case, I've taken this information from the US Energy Information Administration from 2021. Now, the result of our multiplication is going to be our output value, which is going to represent the pounds of CO2 emitted per gas. So how it's actually going to look like? I have deployed Kepler locally on a kind cluster. I'm also running an application that's CPU intensive. In this particular case, I'm using the Kepler Grafana dashboard to visualize all of my information. The first thing we're going to be faced with are three main gauges showcasing the emissions per gas. In this particular case, for coal and petroleum, we actually need to address our emissions. We need to investigate further and hopefully lower them as well. For natural gas emissions, we're doing quite well in this particular case. At the top, you'll be able to see also these emission factors coefficients that are hard-coded. If you're running in a cloud provider, for example, I definitely encourage to use the metrics provisioned by them because you're going to have more granular information about your carbon footprint. In addition to that, with Kepler, we'll be able to visualize our emissions per container, day, and namespace. So for example, if you have a very spiky day, having lots of traffic coming to your application, you'll be able to identify the component that has most emissions, and of course, address that as well. If you have a solution such as namespace as a service, you'll be able to identify the namespace/team with the most emissions as well. Now, the thing is, with these graphs, you can use this in a reversive manner as well. You'll be able to identify the teams with less emissions, and based on that, create guidelines that are more custom to your organization, and actually share them across as well. Now, with Kepler, we are able to create our inventory of our emissions. We are able to observe, and if we observe, we're able to address. This is a very important step for us. The next question is, can we be a bit more proactive in how we schedule our applications or scale our applications based on emissions or having sustainability in mind? The answer is yes, and this is where the KEDA Carbon Aware Operator enters the picture. Before I talk about the operator, however, I would like to very quickly introduce KEDA as well. Now, KEDA is a Kubernetes-based event-driven autoscaler that is able to scale an application based on a trigger defined by the user, which is usually external to the cluster. KEDA was created by Microsoft and Red Hat in 2019. It was donated to CNCF as a sandbox project in 2020, moved to incubation a year later, and last year we're very happy to welcome KEDA as a fully graduated project. And here I'm going to put my TOC hat on as well. KEDA is a great example of a project that transcended different maturity levels all the way to graduation. They started with a greenfield idea, providing a solution on how to scale your application based on external metrics. Then we had this growing usage and contributions for the project. And finally, now KEDA provides an industry standard on how to scale your application based on external triggers. Now, I definitely encourage you to reach out to the community and actually observe how the maintainers interact with different communities or issues coming from the community as well. If you'd be curious into understanding more of the work that the TOC is doing with the project to actually help them reach the maturity level, I definitely encourage you to read through the due diligence documentation as well. All of this is publicly available. Now, looking quickly into the KEDA architecture as well, to scale any application with KEDA, you'll require a scaled object CRD or custom resource definition. Now, the scaled object CRD is going to have two levels of configuration. The first one is going to be the application you'd like to scale. It can be deployment, a stateful set, or another CRD. The second level of configuration is the trigger that you would like to watch and assess in order to scale your application up and down. Now, with KEDA, you'll be able to scale your application all the way to 0 and 1, but more importantly, it works in conjunction with HPA or horizontal pod autoscaler, which will allow you to scale your application to a desired amount of replicas as well. In addition to that, KEDA has a very rich portfolio of external triggers that you'll be able to integrate and use within your production clusters straight away, such as support for RabbitMQ or Redis or whatever events you have within your cluster. Now, let's go back to sustainability. How can we scale our applications based on our carbon footprint? This is where the KEDA Carbon Aware operator enters the picture, and it aims to optimize the carbon efficiency and environmental impact by scaling your application based on carbon intensity. Now, what is carbon intensity? This is going to be the grams of CO2 equivalent emitted per kilowatt hour consumed. So if you're plugging your infrastructure directly into a solar farm or a wind farm, your carbon intensity is going to be 0 or close to 0 because you emit no emissions while consuming that energy. However, in a more realistic example, we're going to have energy coming from different sources. Some of it can be from burning the coal or fuel, some of it can be renewable. As such, we're going to have a varied level of carbon intensity. Now, to scale our application based on carbon intensity, we'll require a carbon-aware KEDA scaler. And this is going to have 3 levels of configuration. The first one is going to be the application we'd like to scale. In this particular case, I'm referencing a scaled object CRD, which comes from KEDA, with the name Mango Voyages. The second level of configuration is our carbon intensity forecast. And there are 2 main ways to actually get that. The first one is to plug in directly into a provider or a grid and get that carbon intensity coefficient. Some of these providers that allow these functionalities are Watttime and Electricity Map. The second way to do that, which I'm actually using in this particular example, is to use mock data. As such, my mock carbon forecast value is set to true. And finally, the final level of configuration that we need is going to be the behavior of our application. How do you want to scale it? The main idea here is that if your carbon intensity is high, you want the lowest amount of replicas, because if it's high, you have more emissions. And vice versa, if carbon intensity is low, you want the maximum amount of replicas. And we'll be able to visualize it as well with the KEDA Carbon Aware operator dashboard coming from Grafana. Now, in this particular case, I have 2 main lines that I would like to draw your attention towards. The green line at the top represents our carbon intensity, and the yellow line at the bottom represents our replicas for our application. In this particular case, we start with a carbon intensity of 530, which means we're going to have a carbon intensity which is quite low and maximum amount of replica, which is going to be 15. Towards the middle of the graph, we can see that our carbon intensity is going higher, and the amount of replica is going to go all the way to 1. And this behavior is going to be replicated through and through based on the carbon intensity coefficient we get from the grid. Now, at this stage, we are able to create inventory of our emissions by using a tool such as Kepler. In addition to that, we can be more proactive in thinking about our emissions by scaling them based on carbon intensity. Now, whilst the technology is the gravitational point of our community, none of it would be possible without people around it. As such, I would like to talk about community sustainability as well. Now, from the beginning, the Kubernetes community operates on the principle that inclusive is better than exclusive. We create, retain, and build contributor communities through open governance, transparency, and a diligent code of conduct. This is what pushes innovation forward and invites everyone to contribute. Now, if you'd like to get involved with any of the projects within the ecosystem, I definitely encourage you to check contribute.cncf.io, where you'll be able to find more details. However, I cannot stress this enough. Contributions are not limited to code. There are many ways for you to be an active member of our community. It can be from providing feedback on how to use an application in production, or feedback in regards to new tooling and functionalities. Perhaps you'd like to be part of creating guidelines or white papers, or get involved within the working groups. All of this work is very valuable, and it's actually something that is led by our tags or technical advisory groups. These are micro-communities that focus on very specific domains, such as observability, security, application delivery, and of course, one of the latest tags that we have created is Tag Environmental Sustainability. Now, these tags aim to put sustainability on the agenda of every single CNCF project out there. One of the latest working group that they have is called Green Reviews. Now, as part of this working group, they aim to measure the carbon footprint or emissions for every single graduated project within CNCF, and hopefully for all of the other projects as well. And currently, they're working quite closely with Falco. Again, a very good time to get involved, because even if you don't have the time to get involved in the working group, you'll be able to replicate some of those practices within your organization. Now, another thing that we should do as a community is to lead for a culture of education and upskilling. This is because we need to scale at the same pace with technology growth. Now, when it comes to leading for a culture of education, we have multiple certifications within this space. We have the professional level certs, which are CKA, CKD, and CKS, or pretty much certified Kubernetes application developer, administrator, and security specialist. Now, we had some feedback in regards to these professional certifications. It presents too much of a high-level entry bar for new community members. This is because you need prior Kubernetes experience in order to pass these exams, because the exam is you facing a terminal, querying the cluster in order to get the results for your answers. We heard this feedback, and as a result, we have created KCNA, or Kubernetes and Cloud Native Associate Certification. This is a multiple-choice entry-level exam that enables anyone with an interest in Cloud Native to demonstrate their passion and get credentials on top of that as well. Following the same example, we have multiple associate-level certification coming in, focusing on observability, security, networking quite lately, and GitOps as well. And as part of the same mission, I have created the Cloud Native Fundamentals course, which is completely free, and you'll be able to find on Udacity. However, in this particular case, I'm aiming to bridge the gap between DevOps and local development of Docker to running your application successfully in a cluster. But more importantly, as a community, we need to remember that we are working on software that changes entire industries and sectors out there and how they approach the platform build-out. However, we still need to diversify our executive leadership, technical and advisory boards, and technical committees as well. As such, I would like to encourage everyone here to continue building a diverse community. We need to create this welcoming environment where new ideas and feedback is welcome, but at the same time to create the space for the next generation of cloud-native practitioners to operate in. And this brings me to the perspective today. So far, we talked about the notion of cloud sustainability and why it is important for the tech sector to observe and address their emissions. We applied sustainability to the cloud-native context with tooling such as Kepler and KEDA. And finally, we talked about community sustainability and why it is important for us to scale at the same pace with technology evolution. And all of this has been possible because cloud-native space is in constant transfiguration. And more importantly, it allows us to innovate for green technology by being aware of our carbon footprint and environmental impact, but at the same time, build a healthy community around it. And without saying, we are hiring. If you'd like to work for Apple, we have an office in Zurich, of course, but if you'd like to work anywhere in Europe or the US, I definitely encourage you to check jobs@apple.com, where you'll be able to find the latest openings. If you have any questions in regards to the interview process or the experience of working at Apple, I'm more than happy to answer. If you have any questions in regards to today's talk, please ask them thereafter, or you can reach out to me on social media, such as Twitter and LinkedIn. This is Gamanji, and I look forward to seeing how you can shape the cloud-native ecosystem. Thank you, and enjoy the rest of the conference.
Thank you so much. Are there any questions? There are questions close. I'm glad, because otherwise I'd have to throw the...
Okay. Hello. For the Kepler, the metrics that you get, that means you get them if you run natively, right? If you're running in a virtualized environment, like you mentioned before, the metrics you get from your AWS, Azure, GCP, or
Right.
how does that work? Yeah.
So the metrics you'd get from the cloud providers are the emission factors, so those hard-coded values. Because if you go back, for example, for natural gas or petroleum, it's like 2.47 or something like that. Those values depend on the provider that you're actually using and running. So, for example, if you use renewable energy, all of those, of course, would be definitely lower. So the emission factors you'll be able to get from the cloud providers. The input value is going to be calculated by Kepler based on the application you run in the cluster. So you multiply that by an emission factor, and then you get your results.
But the real values, like if I run my own cluster,
Yes.
then how do I know these factors?
In this particular case, you'll be able to get them from your energy provider as well. Because currently, again, with COP21 and United Nations SDGs, we have multiple countries focusing on sustainability as well. So now you have the energy providers, the actual energy suppliers, provisioning these values for you as well, and you'll be able to use them to calculate. They're not going to be as granular as you want, but we are at this point where having no data is actually a worse situation. So we are in a position where we're actually going to get more granular data and more precise data as we move forward. But to answer your question, if you have your own data center, or like your own computer behind your desk, you'll be able to use the emission factors coming from your energy supplier.
Thank you.
Additional questions? One in the front here.
So if I run my own cluster and I use something like Kata or Firecracker as a container engine that uses like hardware virtualization, does Kepler still work? Because if it uses the kernel and stuff gets offloaded from the kernel to micro VMs?
Good question. I think this is going to be a very good experiment in POC to work on. Yeah.
I will look into it.
Perfect. Reach out to the maintainers.
Awesome, thanks. Any questions? You can throw it directly.
Hi. There is another problem actually that happens in many places, places that clusters are underutilized. Like you may have your application scaled down heavily, but running your cluster at full capacity. So how are there any like recommendations to measure those things and measure and then calculate emission based on this efficiency?
That's actually a very good question as well. I think there's a lot of clusters nowadays that are underutilized a lot, and perhaps the limits for your CPU and memory is like over-provisioned, like heavily. So this is where the FinOps practices come into play. It's like, how do you observe the cost for your infrastructure? And this is where you'd be able to actually produce those numbers. In terms of observability, of course, you'll be able to use tooling such as Grafana to visualize like how much capacity you have and how much you use. But I think if you want to make a business case for your leadership, you want to talk about money. And this is where it's very important to bring that FinOps practice into play. So I think this actually goes into the category of FinOps more, that in result will have the sustainability impact because you have less compute used and then you're going to have less emissions. So I think it kind of goes into that domain.
Back there is a question.
Do you have any comments for languages that are more environmental friendly? And also, what do you think about this whole AI craze now, you know, GPUs and all that stuff, you know?
Right. Straight on. So I think in regards to using a more optimized or more sustainable programming language, I definitely endorse it. I think there is definitely a move towards using languages that are more aware of our emissions, but at the same time, I do understand the challenge of rewriting your entire application and components. This is not an easy task and definitely not an easy migration as well. But there is definitely this kind of point of decision making where you think about emissions when choosing a programming language. So it might be, I wouldn't say late for existing applications, but for new application, this is already happening. And when it comes to AI, and of course, like running all of these models, they are quite CPU and GPU intensive as well. I think this is something that it's emerging when we're talking about sustainability because these are very heavy workloads as well. perhaps this is where I think it's very important for us to understand our emissions and think, like, do we want to run this, like, or perhaps be a bit more scarce with how we run these models or decision-making of running these models as well. So I think this is a domain that is still emerging. The overlap between AI and sustainability is not as pronounced, but this is where conversations like this are very important for us to raise that awareness. So I think it's still emerging.
There is still time left for one additional question. And if not, thank you very much, Katie.
Thank you very much.